Well, hello there. Didn't see you. So, how do eosinophils evade their toxic granules? Eosinophils are a type of leukocyte that are mainly found in connective tissue below epithelial regions and in the blood. They originate in bone marrow and have many cell surface receptors which can bind to various proteins. The location of eosinophils implies a role in defense against invading organisms. Upon activation, eosinophils release the contents of their granules out of the cell. These granules contain arginine-rich bases which are toxic to most cell types. The highly toxic granule proteins released destroy invading microorganisms and also cause damage to the surrounding area. This stimulates inflammation. In bone marrow, interleukin-5 release stimulates eosinophil production. So as not to damage the organism, eosinophil numbers are only increased in response to antigenic stimulation. But why do eosinophils not cause themselves damage due to the toxicity of their granules? They are able to resist damage due to the presence of survival factor cystatin F, or CF. CF, also known as leukocystatin, is structurally unique and almost exclusively expressed in the cells of the immune system.
It's cold.
Were there not 4 of you?
Yeah, Debbie was representing the university in football.
I wonder if they'll win something this week. Unlikely, she's more use here. Okay folks, differential analysis. Why do these eosinophils not kill themselves with their toxic granules?
So I knocked out cystatin F in mice, and these CF null mice showed normal eosinophil numbers, but the granularity in those cells was significantly reduced.
Okay, fine, but how do we actually know it's cystatin F causing this effect? I'm sure you have something to contribute, Aitken.
Actually, I'd already thought of this because I didn't think her research would be sufficient.
I'm not interested in your bickering. Can we get back to the science, please?
I re-expressed CF in the null mice before triggering allergic inflammation. GFP was used as a marker of CF expression. I found a strong preference for cells with restored CF expression, as over 90% of originally CF null cells were GFP positive, showing that re-expression saved granularity.
Finally, we are getting there. What else? Milligan.
Did you eat all the reds?
Milligan!
I compared the allergic CF null and the wild-type eosinophils under an electron microscope. The wild-type eosinophils showed high granularity and normal major basic proteins in their crystalloid cores, whereas the CF null eosinophils, on the other hand, rarely had a crystalloid core, were amorphous in shape, and were sometimes incomplete, suggesting that they had burst.
Yes, but you haven't really answered the question, have you?
Essentially, CF null eosinophils die over time. This is possibly due to their toxic granules. In CF null mice, there was rapid loss of high granule eosinophils compared to wild type, but low granule eosinophils did survive in the CF null mice.
Building on Sand's findings, eosinophil granule abnormalities in CF null mice are caused by dysregulation of cysteine. Through the use of cysteine protease inhibitors, granularity of eosinophils was restored. All of this suggests that the regulation of cysteine protease activity is a primary function of CF.
I concluded that granule integrity was required for eosinophil expansion during parasitic infection. I studied 2 ways, allergic inflammation, asthma, and then parasitic clearance. Lung inflammation was lessened when CF was not present, which caused a physical change to the lung. CF null mice failed to clear the infection at all and had raised eosinophil levels in their blood.
Okay, this makes sense. You all seem to have covered your bases here. See, this works well. You do the work, and I get all the credit. Has somebody spoken to an expert?
Professor Colin Watts, leading expert. I happened to speak to him a few weeks back.
These eosinophils are known to cause a lot of the damage in the lungs of asthmatic people. Certain types of asthma are characterized by a big infiltration of eosinophils, and it's known that a lot of the damage is done by eosinophils. So controlling eosinophils is an attractive therapeutic option.